Good morning. All right, here's the answer to your do now question. So suppose that 500 kilojoules of energy were transferred to water at 45 degrees Celsius. What mass of water would be brought to the boiling point? So we're just bringing it right up to the boiling point. We're not actually boiling the water. And we know that the boiling point of water is 100 degrees Celsius. And so here we have our temperature change. Here we have our mass. Here we know what the specific heat of water is. So how I wrote that was C with a little W here to indicate that that was for water. And so now we can just plug everything in and figure out, what are we looking for? What mass of water it was that we brought up to the boiling point. So all we need to do is plug everything in and then solve for M. So let's go ahead and do that. So we have our Q is 500 kilojoules. That equals 4.18 joules. I'll write it like this actually. Joules per grams degrees Celsius times the mass, which is what we're solving for, and the delta T. So we have the final minus initial. So final is 100 minus 45 degrees Celsius. So here my degrees Celsius is going to cancel out, but my mass isn't going to cancel out yet because that's what I'm solving for. So when I rearrange this equation, everything will work itself out so that I'm left with grams. Now I also noticed another problem here before we get started, and that's that I have joules here but kilojoules here. So remember that this K basically is taking the place of 3 zeros. So I can expand this and write out 500,000 joules, and that would be the same thing. So let's work this out. So first I'm going to go 100 minus 45. So my temperature change here is 55 degrees Celsius, but again that Celsius cancels out. So I'm just going to start rearranging my equation and moving everything over here. So 500,000 divided by 55 equals 9090. Then I'm also going to divide by, so I'm going to go ahead and do that. Divide by 55, divided by 55. So now I have 9090.9 joules, and that equals 4.18 joules per gram degrees Celsius canceled out, times mass. So now I'm going to divide by 4.18 joules, and this gram, because it's on the bottom here, when we are dividing it, it gets flipped upside down and the grams goes on top. So I just wanted to show you how the units work themselves out. So joules cancels out, we're left with grams. So let's go ahead and do our math. So again, over here I need to divide by 4.18. And my mass is, I'll go ahead and write it up here, 2,174.858 grams. How many sig figs do I need? Let's see, I have one sig fig here, 2 sig figs here. Boiling point, we could say this has infinite sig figs because we know what the boiling point is. So let's round to 1 sig fig, so that would be 2,000 grams. There's my answer. So now let's go to a new question. So my next question for you is, you grow up and you decide to become an ice sculptor, and you make a beautiful masterpiece in the park. It weighs 2.4 kilograms and is at 0 degrees Celsius, obviously because it's ice, but the air begins to warm. Your sculpture in the park this winter begins to melt. How much energy is absorbed by the ice as it completely melts? So far this is the equation that we have. So see if you can go ahead and solve this one.